This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers, retirees, students, and other not-so-nefarious characters who have limited space, limited money, and limited time. My name is Neil. Welcome. The prototyping system did not pop out of thin air. It is based on an article I read decades ago in a publication whose name I don't remember. Didn't even remember the date it was published or who wrote it. This video presents some of the research relevant to this project. I started this Google search and I started looking through this subdirectory, Holly, which contained this particular article going way back. The date is February 1975, and on the cover of Radio Electronics magazine, I found this cover article, New IC Breadboard System, Build It for Your Bench. This was the article that got me started off a long time ago. I was determined to build this thing. Article, rather descriptive, by C.D. Wadsworth, describing how to construct his version of what I'm calling prototype system, and various and sundry other stuff. It's kind of interesting when I browse through this. This stuff goes back to 1949. Really? Well, this guy was really performing a service. Now, taking a closer look at this original article, the 1975 article, I'm looking at the front page cover, and what it's got is two sets of power supplies. Each one is a tracking power supply, so there are two dual tracking power supplies, and they are ranging from plus and minus 5 volts to plus and minus 18 volts on the top. So he's got two sets of binding posts and some feed-through connectors. The left side contains, I'm guessing, voltage adjustments, and lower on the left side he's got a waveform generator with waveform types. The waveform generator is, according to the article, capable of generating sine, square, triangle, and ramp waves. The frequency ranges from 100 to 1 megahertz. And so you have a coarse adjustment for frequency and a fine adjustment for frequency and an adjustment for the amplitude that goes from 0 to 3 volts. In addition, in terms of inputs, he's got debounced switch and a debounced momentary toggle acting as a push-button kind of switch. And sitting on top of that is screwed into the top a breadboard socket, actually several of them. And below the breadboard socket is a set of, 12 buffered LEDs that can indicate on or off situation if you're testing digital circuits. Also on here, it looks to me like he's got some additional power supply connections, and I don't know, that's what it looks like. The case looks like it's a very solid, perhaps aluminum case. The enclosure is flat on top and sloping on the sides, so you can more easily read the analog meters that he's got put on to monitor power supply. And the meters' sensitivity are switchable from, in the case of milliamps, goes from 1.5 amps to 150 milliamps. There is a voltage meter and some sort of voltage adjust to the left of that, and a switch that selects the various power supplies. Don't know, it's not clear to me whether he's got a dedicated plus 5 volts on there. I thought he did. I don't see any monitoring for it. Maybe it is. Maybe he does have it. And that would be the set of connectors on the immediate left of the breadboard. I don't like a flat top on the enclosure. It means things can drop in and get annoyingly in between things, and makes it difficult to pick up. Also, it makes it difficult to see exactly what's going on the breadboard. If you put components into the breadboard, you're going to have an obstructed view of what's going on. Other than that, it's an interesting first cut at doing what I'm calling a prototyping system, new IC breadboarding system. Now, the next item that I found in radio electronics is an article from 1980, and on the cover page is "Build this experimenter circuit design station for CMOS." And what it's got, 12 LEDs on top that are buffered to check the logic state of the CMOS circuit. It's got some push buttons and toggle switches, 4 debound switches, and it's got 2 clock generators, pulse generators, that are two-phase generators, meaning if one goes positive, the other one goes negative, 180 degrees out of phase with one another. And that's kind of interesting. I was wondering just how useful that stuff is, and whether in this prototyping system I'm building, I should consider building 2-phase or a 4-phase set of clocks, which, if you're trying to study the effects of clock pulses on discrete logic, might be necessary, or at least desirable. I don't know. I haven't formed an opinion on this at all thus far. The construction of this, it looks like it's a phenolic single-sided printed circuit board, where the unclad side of the board is being used as a panel for the top of this, what appears to be plastic enclosure. And I have some serious issues with that kind of construction. First of all, it's exposing all of these components to you, the user. You've got all of these integrated circuit sockets. You've got some disc capacitors all sticking up, waiting to be brushed off, collided with, broken off. These systems have to be very robust. You're putting together a circuit, breadboarding it, you're pushing integrated circuits in and prying them out, pushing leads in, trying to figure out why something works or doesn't work, and you're not going to be treating the equipment all too gingerly. This looks like it's not quite robust enough to fill the bill. Doing my Google search, I came across LN Co., which does all kinds of educational electronics, toys, things of that nature. There's a digital analog trainer. It looks interesting. Computer interface trainers, microprocessors. This is a little too bare bones for me. 125 volts to 15 volts at 0.25 amps. Power supply, a bunch of LEDs, but not very much in the way of breadboarding. Now this looks interesting. It comes in several versions, one of which they supply the tools, the T version. I would be reluctant to look at the price on these things, but they do have a number of interesting features. Plus 5 volts and 1 amp, which is essentially what I would build into a system. I wouldn't build anything more. Well, maybe 2 amps. 0 to 20 volts at 500 milliamps, along with 0 to 20 volts negative at 500 milliamps. Plus 12, minus 12. They've got a 30 volt AC center tapped 1 amp available for prototyping, a bunch of uncommitted components, switches and potentiometers, a function generator, sine, square, triangle, TTL pulse, high rise time, logic switches, eight logic switches, TTL compatible or linked to the positive supply, which is another good feature I need to think about. Uncommitted potentiometers, 1K and 10K. Those are good things to have around if you don't want to go dipping into your bins of parts and you need a quick 1K resistor. There it is. 8 red and green indicators for digital signals. So this is kind of interesting. The fact that it has a digital voltmeter attached is also interesting, because it gets me to thinking, well, maybe part of a prototyping system, if you're going to have it self-contained in one enclosure, perhaps within that enclosure should be some form of digital voltmeter. Next vendor I came across in my Google searches is the Global Specialties Corporation at globalspecialties.com, and they put together quite a number of these prototyping systems at wildly different prices, some of which are on the high side. But it's interesting is that they have so many different models of what they call electronic trainers. Geez, this is almost $1,100 worth of, what do they call it, electronics design workstations. Looking at the features here, they've got 3 different models of this thing. This is the most sophisticated, which is what I would start off with. In terms of looking at its features, I compare the features of their product against my functional requirements. If one of their features is not in my functional requirements, is this an error on my part and the analysis? Is it something I should have put into the analysis? Is it something that's totally unnecessary? The enclosure looks like a little too steeply inclined, but it's difficult to tell from this angle. The top panel is difficult to make out also. I can see switches that look like they're riveted in, and not just sitting on top of a printed circuit board, but the whole thing may very well be a printed circuit board panel. Got a lot of breadboarding space. I don't know how necessary that is. I guess in one sense you cannot have too much breadboarding area. In the 507 model, they've got plus 5 volt supplies, 0 to plus 20, 0 to minus 20. They've got a 12.5 volt AC available somewhere, I think in the upper right corner. Function generators going from 0.1 hertz to 1 megahertz in 7 ranges. Dedicated TTL pulse synchronized with the waveform. Pulse generator is separate from the function generator. Logic switches, they do have uncommitted components along the lines of all the others. Switches, binary BNC connectors, a couple of pots that are uncommitted that can be used as components in breadboarding. I noticed that all of their models have speakers as output, 8 ohm speakers at low wattage, and that is useful. If you are developing audio circuits, it's really nice to have reasonable quality speaker so that you can hear what's coming out of your circuits. That's at least as important, if not more important, than being able to see the output signal on an oscilloscope. Also have USB outputs. It's unclear to me whether that is actually connects to a computer or whether it's just powered output to power USB stuff. Frequency counter and a digital voltmeter of sorts. It's also got output LEDs with adjustable trigger points. So this stuff looks interesting. My normal objection to printed circuit panels may not be applicable in this case, because I do see that almost every component that I can look at has got fairly solid attach points. It'd be really difficult to tell without having this in hand. Is it sturdy enough to withstand the pressures of actual prolonged use under a prototyping environment? This video presented some of the research relevant to the project. In the next video, we're going to summarize the functions and specifications of the units we encountered during this research. We're also going to flesh out the functional requirements and specifications of this particular project, the prototyping system, what is required, what's desired, what's frivolous. And finally, we're going to make a decision: buy, build, or bail. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. It's not all that difficult, and I promise to read it. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, vector graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.